this video, I'm going to explain the 30, 60, 90 triangle relationship from trigonometry. To start, what I did is I constructed a square and I inscribed a circle within it. And for simplicity, we're just going to let the radius be 1. And then for this quadrant, I divided the square into 4 equal dimensional segments. So basically, these are all cut in half. This node is just half of the radius, so this is going to be 1/2. This length is going to be 1/2. This length is going to be also 1/2. And then we're going to let this angle right here be equal to theta. And therefore, this angle is also theta due to the vertical angle theorem. And that just shows it's basically if we rotated this, it would be the same, easily verify they're equivalent. But we also know that they're projecting the same vertical length of 1/2. So anytime you have a triangle, and then we have length L, this is the angular distance theta. So basically we know that length is directly proportional to theta, but also the radius. And the reason for that is if we draw like a circle, we connect and we draw another circle surrounding it. So what we have is if we were to draw a triangle, we have this triangle right here inscribed within, and then that triangle. And if we call this length 2, call this length 1, we know length 2 is greater than length 1 since radius 2 is greater than radius 1. And the angle is equivalent, so the angle keeps it's static. It's a static angle, but the radius changes, it increases the length. So basically, although, so it's really proportional, of course, to the radius, but the angle determines the length. If there's no angle, essentially, so a larger angle, if I project a larger angle, it's going to give a direct proportional distance length. So right here, since they're all projecting 1/2, so we have the distance here is 1/2. So this is going to be theta, and as well as right here. And then what we want to do is we're going to take this node and we're going to shift it down to here and see what happens from there. So basically, since this line is a radius, so what we're going to do is we're going to drag this line and it's going to shift down to here because it's a radius, stays the same. And then we notice we're going to take this line right here and figure out what happens when it gets shifted down. So normally if we took this entire segment and we were to shift this down vertically by distance 1/2. What we notice is this is shifted down, it has to shift in a horizontal direction the same distance as this delta x. So we'd have to cut this to, let's say, this distance right here is delta x. So what ends up happening is this is a new projection of the entire line. So therefore, because this is a subset of that, we essentially, we're just going to focus, because this angle is equivalent, even if we take the entire line segment, which we did, and because it's essentially, as we're dragging it down, it's going to create the angle right here, theta, because we're essentially we're changing this distance right here by the same, or theta, and therefore, so basically we're dragging this node and we're shifting it down to here, and it's connecting here, and therefore, because we dragged it down theta, we essentially flipped it, and over here, this distance is also going to be theta, so we draw right here. So we took this entire line segment and we just shifted it down to this node. So, and then from there, so this is the second line, entire line segment, and then from there, we also have, we're going to focus on this node right here, so we're going to focus actually on this line segment. And then if we drag it down, what we notice due to symmetry is as we shift vertically down 1/2 in this upper quadrant, we have to shift horizontally 1/2. And then if you notice the distance delta x, we're going to shift vertically, horizontal delta x, we're going to shift vertically delta x. So that's why, so this third line segment gets projected. and essentially we're going to end up right here. So then we also have a fourth line segment. And we notice with this line segment is interestingly, if we so basically if we're going to shift from here and down, we know that the vertical distance is going to be greater than 1/2 because we have to create like a circle with the same concavity. So essentially, as we're progressing along this line, so this is like a circle, we're shifting the node, and then if, in the vertical direction, we're going to find that this is going to be, I believe should be delta x, and so we're going to have a distance. It's going to shift, and then we have delta x, so somewhere around here, and because we're going, again, we're taking that node, because we're collapsing vertically 1/2, we're going to shift horizontally in this distance, delta, by 1/2. And so essentially we're going to have this line segment, or it's going to be on here. So then now we have a 90-degree angle right here. And so therefore we have theta, theta, and theta. So that creates 3 theta, and we set this equal to 90. Therefore, theta is 90 over 3, which is 30 degrees. So there we have it. So essentially what we did is we drew, so we have a 30-degree angle, and if this is 90, that's 60. So 30, 60, 90 triangle. We know this is 1/2, and we know this is 1 because that's a radius. And then therefore we know if this is x, we're going to use a Pythagorean theorem. So we know x squared plus 1/2 squared equals 1 squared. And then we shift the 1/2 squared over, so that's 1/4, so that's x squared equals 1 minus 1/4. And then this is just going to equal 4 divided by 4 minus 1 over 4, which is equal to 3/4. So if x squared equals to 3 squared, 3/4, that means x equals the square root of 3 divided by 4, which is essentially root 3 over 2. So therefore, this converts to, so 30, 60, 90. So we have root 3 divided by 2, and 1/2, we have 1. Or this is 1. So basically, when we use trigonometry, we use a relation or mnemonic device where we use SOHCAHTOA. So corresponds, if we take sine theta, sine of the angle, is this opposite over hypotenuse. The hypotenuse is a radius. So basically we know the opposite side, so from this angle the opposite side's right here, so it's going to be y divided by the radius. But we know y is 1/2 in this case, and the radius is 1, so that's just 1/2. And then we have cosine theta is adjacent for the a, so adjacent divided by hypotenuse. And that's just x over r, and that's just root 3 over 2 divided by 1, which is root 3 over 2. And then we have tangent, so we have tangent theta, which is opposite over adjacent, and that's just equal to y over x. It's equivalent, we find the slope, and then that's just 1/2 divided by root 3 over 2. And of course, this is you take the reciprocal, so you have 1/2 times 2 over root 3. It's cancel, and you're left with 1 divided by root 3. So these are the trigonometric relations, but one key factor is if when it comes to symmetry, you notice if you draw a circle, key factors, like if we took the 30 degree, so 30, but if we take a 60 degree, so if this whole angle is 60 degrees, but then therefore this angle is 30 degrees. So all we're doing is it's symmetric. So we take this node and it becomes, if we're rotating it, we flip it, it's this line, and then this node is over here. So if we take this distance, we call this like B, this distance is A. Well, this new distance is equivalent to B. It's flipped vertically, and then this is A. So, but you notice when we do a 60 degree angle, we're really projecting down here. So that's why, you know, like we have a square or rectangle. I just drew a rectangle, and I just drew it like this. So of course, we know that this is B, and then this is A. You know, this is 60. So of course, we know A, or B, was 1/2, and A's √3/2. So now we flip the relation. And the key way to remember this is we know, notice how if we draw a line y equals x, these are symmetric. Over on this side, we have the change in y is less than the change in x. And then over on this quadrant, we have change in y greater than change in x. So if we're looking at the first relation, we know that B, so B is 1/2, which of course we know is less than √3/2, which equals A. That's the x value. So this is like y, that's the y value, change in y, and this is like change in x. So change in y is less than change in x. And then on the other quadrant, we have delta y becomes now A, which is √3/2, which now we know is greater than 1/2, which equals B, which is delta x. So basically now we flip it. So that's why, like over here, you know, we have cosine 60 is now √3/2. And we know that this actually equals to sine 30, so the y. And we have sine 60. So sine 60 is I think I got that mixed up. So this should be cosine 60 is going to be 1/2. So that cosine 60 is going to be, let me get the eraser. Cosine 60. So cosine 60 we know is 1/2, which actually equals to sine 30. So notice that cosine 60 is the x portion, and then we know sine 30 is the y. So basically the x now equals y. So now we have cosine 30, or cosine, let's just make this sine 60 is √3/2, which equals to cosine 30. So sine 60 is the y component, and then of cosine 30, that's the x component. So we flip the y and the x, essentially. And of course, if we take, we take the x proportion, so we know that cosine 60, which is 1/2, is less than cosine 30. Because this was 1/2, and this is equal to √3/2. And we know that cosine or sine 60, so sine 60 is root 3 over 2. We know that this is greater than sine 30. So the y proportion, we're focusing on y of this, the 60 is going to be greater, and of the x value, the 60 degrees is going to be less. So this is like, delta x is less than delta x. So delta x is, in terms of 60 or degree angle is less than the delta x in a 30 degree angle. And that's just a projection. So this is kind of like how you can always remember it, because on a circle, logically that's what, so if it's 30 degrees, if you know that delta x is a greater value, it's going to be root 3 over 2. And then vice versa. On the, if you're doing a 60 degree angle, you know that delta y is going to be the greater component. And of course that's going to be that's why sine of 60 is greater. It's going to be the root 3 over 2. So that's a good way to remember it. And that's all I have for now. And I hope you enjoyed.